Hello, friends. I am glad to see you again on the greatest conference of the world, conference Heisenbach. And let me introduce our next awesome speaker with amazing talk, Amit. Hi, Amit. How are you?
Hey, Evan, how are you? Hi, folks.
Me fine, thanks. Where are you now?
I'm in Sunnyvale, California. It's 3:45 in the morning.
Uh-huh. And I think you have a lot of sun at your place, right?
Yeah. In
Uh-huh.
few hours there will be sun. Yeah.
Here in Russia, St. Petersburg, it's not so hot. Okay, so I think you will introduce yourself during your talk. Are you ready?
Yes. Yeah. I'm good to
Let's do
go.
it. Have a luck.
All right. Hey, folks. My name is Amit Good. Um, Thanks for joining in. So today we're going to talk about testing in production and learnings from DoorDash. And I'm glad to be here. We can get started. First, let me introduce myself. I'm from natively from India, and I've been based in Sunnyvale, California, for a few years now. I've been in the industry and have about 18 years of experience working with both big and small companies, figure out their architecture and scaling and developer velocity. Currently, I'm with DoorDash. It's a food delivery and grocery delivery business operating in few countries, including United States. And currently, I'm helping them scale, implement rapid and safe development and deployment strategies. Feel free to connect with me on LinkedIn. Happy to connect one on one. All right, so let's dive right in. Uh, I understand there is a bit of a technical lag here, but raise your hands if you do not struggle with keeping your staging or QA environments working. Yeah, so this is this is more of
So hands will be raised right now. Guys, please send something for us. Okay, hands are raising.
cool. Yeah, so this is supposed to be kind of a question to get us excited about what's coming in, but maybe this is something that you relate with, that having to keep up with staging environments is not easy. But what if I tell you that testing in production will make this problem go away? And then that's what this talk is about. So let's talk a little bit about software development at DoorDash. And this is to give you an understanding of how the tech landscape is at DoorDash. So DoorDash is primarily a Kotlin shop with Python and Node as well, serving both front end and closer to the web and mobile side of things. So, but primarily Kotlin is used for backend development. There are tens of millions lines of codes of Kotlin, Node, and Python services, Python code in multiple applications or services. So in terms of applications and services, there are hundreds of those, around 200 front end developers working on 30 front end poly repos, 700 around back end developers working on 200 different back end poly repos. And these repos are Git repos and serve multiple one or more applications or services. So it's typically a microservice stack at DoorDash, and with hundreds of microservices or applications. And in terms of the velocity, so developers typically merge about thousands of commits per day, and this is something that will probably give you an understanding of what the how the velocity is and how fast at what pace the development occurs. And let's talk about the problems we were facing then. So dedicated testing environment staging was unreliable. It is lack of SLOs, service level agreements, and service objectives, and developers pushing unreviewed code into this environment, making it unreliable. So the code that is being tested is could be bug buggy, and this code getting pushed into environments and other people relying on that for it to be stable made it really the not a reliable way of testing out your code. And operational cost we have to pay for maintaining this additional staging environment. That's not going away anywhere. The fidelity of test running was limited to functionality correctness, because since the scale of this environment is smaller than the production, we cannot push it to the capacity that production is working on. So the function so it was the functionality of this environment was reduced to just testing features, for example, whether they work or not, but not the scale. Also, let's say there is uh, an event happening where we expect more traffic, let's say holiday event, or promotion campaign, or some such event. During those events, we were not able to gauge whether the production stack would actually hold up, and that's why there is a guesswork needed, because we cannot really push traffic onto production reliably. So and the capacity planning on the staging environment was not apples to apples when it comes to comparing with production. So these were some of the problems we were facing, and and but, let's talk about this problem a little more, and this is kind of visualization of what we have had, and it is kind of typical in a lot of companies where we have different QA environments, and these QA environments mimic production environments, same number of applications, databases, message queues, and this is kind of simplistic model, uh, but this is to give an idea that each QA environment has its own ingress, so you can hit QA environment one separately from QA environment n, and so on. And a developer would typically reserve this QA environment, test out their changes, and then move on to the production deployment. And so maintaining these set of QA environments, which are distinct from but similar from production environments, is an operational overhead. It cannot scale, and um, and and and, and to a lot of extent, there is a lot of overhead in keeping the QA environments in sync with production environments. For example, version X of application running in production should match with that in the QA environment. And whenever that version is changed, we we will want to make sure that each of the QA environment is in parity with that version. So there is a lot of deployment challenges, and the main problem is the scale issue. If if we want hundreds of thousands of developers to be working in parallel, testing their changes seamlessly without having to be blocked by each other, this is a big hindrance. And so the solution we kind of landed on is testing in production. So in testing, the testing in production is about collapsing all your QA environments and your production environments into one, in such a manner that there is just one stack, and that stack is able to handle both your test traffic and production traffic. And we isolate the two make sure that one does not affect another by using multi-tenancy, and we'll talk more about that. So singular multi-tenant stack to operate and scale, and there is no question of keeping the parity between any two stacks, because there is just one stack. If I'm testing service A, I will be replacing service A in that stack with my uh, um, pre-production code, say A prime, and but the rest of the nodes of the call graph are going to be production. And that brings in high fidelity of testing. So whatever I'm testing there, except for my applications that I want to test, everything else is actually production. Load testing becomes more accurate because you are actually using production stack. So there is no question about the reliability of the numbers you're getting as part of your load testing. So what are the challenges in getting there? We kind of are envisioning this solution, but to get there, we have a set of challenges, and let's walk through those. So first is setting up the infrastructure in order to make our microservice application stack multi-tenant. So we used OpenTelemetry for context propagation, and OpenTelemetry is an open source project which works with multiple number of languages. It allows you to automatically instrument the application code so that it propagates certain context when a request moves from one application to another application. And this is done. This OpenTelemetry supports RPCs like gRPC, HTTP. It also supports async models like Kafka, SQS, and so on. So OpenTelemetry is typically used for distributed tracing, but this is the added. But the way distributed tracing works is using context propagation, and that's what we were interested in to make our microservice stack multi-tenant. So OpenTelemetry for context propagation, and then we have a set of infrastructure components that are used at DoorDash, and we have typically platform libraries to access those infrastructure components. Here, the idea is that we make the platform aware of tenancy, so that let's say you're talking to Redis, you make a request to Redis library, and that library understands that how to read this context from this request, and the context will have information whether this is a test request or a production request, and then talk to the correct Redis cluster. And so making the infrastructure platform aware of tenancy is what it takes to set up the infrastructure overall. So this includes service mesh, Envoy, Istio, and so on, database libraries and proxies, and like I said, libraries for all the infrastructure components. There is also another aspect of making sure the traffic policies like circuit breaking, load shedding, rate limiting, they are tenancy aware as well, so that if there is no noisy neighbor issue, if test if a test, let's say in my previous example, if my A prime is behaving badly, we don't want to penalize production traffic for it. So these traffic routing rules are aware of tenancy. Testing in isolation. So like we saw in the earlier slide, so we have A prime here, and ability to route traffic from route traffic to A prime instead of A is what is needed, and this can be done at various layers. Service mesh is one good way of doing that if there are already interceptors or middlewares in place, and that is another way in this can be achieved. And this allows the flexibility. For example, if you were in a continuous integration CI environment, or if you want to if you're in a continuous deployment environment where you want to automatically test out changes, you have the ability to spin up these kind of sandbox environments on the fly and route traffic to it. And uh, your test that you run, the set of tests that you run, will inject the proper headers to make sure that the traffic gets routed to the sandboxes that you're spinning up. Similar mechanism can exist for async workflows as well, even Kafka's. And uh, and we'll talk more about the data isolation. Here in this example, A prime is using its own database versus A, which is has its own production database. Feel free to stop me if there are any questions. Let me just check.
Yes, there is one question about the cost. What is the cost of huge failure on production in case some critical issue was deployed in production? It means doesn't those cost larger than cost of for maintain actual staging? What is the time for recovery, rollback changes to return production to the stable state? So 2 questions.
Yeah. So let me take the first one first. So yes, here we have to be really mindful of the fact that we are using production stack for testing, and to mitigate, to eliminate any side effects from doing that, is it going to be crucial. And being able to stop test traffic at will, having those choke points are going to be crucial. For example, if test data is polluting into production database, and that is polluting the business metrics, for example, we will want to stop the bleed, and then figure out how to fix that. So yes, those checks are going to be very crucial, and something that needs to be worked through. So and I'll talk a little bit more about that as well. So tooling is very important here, being able to detect that these leaks are happening, and prevent those. And we can talk more about that in subsequent slides. So the next question: what is the time of recovery or rollback changes to return to production? So there is no kind of we are not switching back and forth from production to test stack, really. So this is live kind of a system, and the test traffic is flowing. Test traffic is could be flowing through different number of sandboxes. So my test traffic would be flowing through sandbox, A prime Avenir's test traffic would be sending. So test traffic could be flowing to A double prime and things like that. So the traffic itself has headers which will tell us which route to take, and the routing mechanism, like for example in service mesh or wherever the routing happens, they're aware where to route this request based on the request headers. And for production will always go through production. Production will always go through A, no matter what. So there is no kind of switching back and forth. It's about creating these custom call graphs by hot swapping nodes in the call graphs with sandboxes, and then pushing traffic which has the right headers which make use of those sandboxes, if that makes sense.
So there were no big crashes of full production.
Correct.
Right?
Yeah, exactly. Maintaining data isolation. So this is one big area on how exactly to do this. The real challenge here is there is no good open source solution which allows us to do this. So there is a bit of uh, investigation and platform work that might need to be done. So idea here is that we want the data to be isolated between production and test. And when I say about multi-tenancy, this is purely a multi-tenant environment, and test is just one of the tenants. So whatever we are speaking here applies to other tenants as well. For example, if you have a different line of business, and if you consider that as a tenant, this discussion applies to that as well. So we want to isolate the data between test and prod. And one way of doing that is, let's say, add a column to every table that tells us what tenant this data belongs to. And there are advantages of doing it this way, using separate column, because then if you do load testing, then you're actually exercising the same database, same table, and that brings more fidelity to the load test that you're doing. Um, yeah, and a separate database can be used for test database can be used for destructive DB testing. Let's say you want to try out schema changes and so on. There are other mechanisms like separate table, separate database, or separate cluster, for example. But then that reduces the signals that we get from load testing. So that's the reason using the same column is more apt. Organizational adoption. This is another challenge, really, because when we are retrofitting this into an existing architecture, we can't flip a switch overnight and suddenly make everything tenancy aware. So we have to work a flow at a time and figure out how do we do the data isolation, how do we make sure that the context gets propagated, and so on. So there are ways in which we can centralize the adoption to some extent. For example, open telemetry can be applied to, let's say, the Docker image that is getting used by all the applications. So that makes it easy. Suddenly, everyone has open telemetry with this strategy. But then the next set of things, like how do we do the isolation of uh, databases, and for example, so that will need to be worked out and reasoned out for each of the applications involved. So organic adoption can be slow, and but centralizing some aspects of it can be a solution. And and we'll need to work one flow at a time instead of hoping that we will get the entire tech stack on testing in prod overnight. Uh, yeah, so there are other aspects like gradual rollout of new versions to minimize regression. For example, new OpenTelemetry version comes along. We want to make sure that we roll it out gradually so that there is no regression, and these mechanisms will need to be worked out on how this rollout happens. Uh, yeah, this is one of those areas, and the question uh, that was asked. So OTEL here is open telemetry context propagation, and this is one of the biggest challenges we have had. That, let's say, there is break in propagation when service A talks to service B. Suddenly, um, at B we don't have the context, and we can't tell whether this is test request or production request, and then we have to choose between the one or drop the request altogether. In either case, there are consequences, right? So so being able to detect this leak happening is very crucial, and we need proper tooling to be able to do that at various levels of the stack, uh, and being able to alerted when this leak happens. So in the entire call chain, we want to know that leak is happening and where, and then we can go and dig and try and find out why that is the case and fix it. So this is important. Well, typically, once we have this in place, it happens due to regression. Let's say a new library was rolled out, that library has an issue, um, or yeah, uh, it's typically because of a change that the leak starts happening. As soon as we identify what changes caused it, we roll it back, and we are back to normal. So that's the goal, mm, that we want to aim for. Other, I mean, but there are other tricks that we have employed, like auto updation of library versions. For example, if we do detect that this version has a bug, and but instead of waiting for all the services to update their libraries to this newer version, we use auto updation and make sure all of them are up to date. Let me see if there are any questions.
Yeah, there are two questions, and both of them about load testing. So, if you have the same database and you're making load testing, it will affect production, right? So, how is this problem solved without DB separation?
So, yep, and so that's the purpose of the. I mean, one of the purpose of the load testing is to uncover problems, right? And yes, if your stack is going to be able to take, let's say, 1.5x traffic of the peak, and you suddenly start pushing, trying to test whether it can take 2x, there you will uncover some bottlenecks, and that's when you will want to stop and figure out how to scale that. So I don't see that as a real issue. Really, it's a symptom of some aspect of your stack not scaling, and that's what we would want to address.
Do you separate sandbox between hardware? Do you place it on separate hardware?
Yeah. So at DoorDash
No, it's not necessary.
at DoorDash we use Kubernetes, and these are just pods that are getting used. So they're in a separate cluster, and that's one way of doing it. But idea here is that if you're doing load testing, will need to make sure that actually, okay, for load testing, one thing to note is that for load testing, we are using the production stack. There are no sandboxes involved, but and sandboxes are mainly for feature testing, and for that, the instance probably may not matter as much. But if you really want to use sandbox as for stress testing, then you will want to make sure that it is same as your production spec.
And also, I think you're using cloud, so you can increase your system while you have money, right?
Yeah,
Okay.
definitely.
Okay, and the third question is if you have a test database, does it mean that you use in fact staging database, or you execute tests on some synthetic generated data?
So idea here is that we want to use production DB and production tables and have a separate column that differentiates whether it's test or production. This brings in high fidelity for load testing. If you are doing destructive testing, yes, then you for those kind of tests, you should use a separate test DB, which you can trash at the end of the test and throw it away. But the data itself is synthetic, right? You are creating test, let's say, if it's a test order or test users, test actors involved. So it is going to be synthetic data depending on what the test is doing. And let's say you create a test user, you create an order, you execute that order, and that creates a bunch of data across the system. All of that data will be marked as test, and it's all synthetic. So yes, data is synthetic, but it lives in the production DB.
Good. Thank you.
So what are some common pitfalls? Like I mentioned, context propagation correctness is the hardest problem to solve. And like the question that was asked earlier, sensitivity of side effects, this could vary from organization to organization. And for this, right tooling is the key. Make sure we have alerting in place, detection is in place, and so that we can, if something wrong happens, we are able to detect it quickly and detect quickly what change caused it and roll it back. Data isolation might need changes to the application business logic. This is something that we should be mindful of, since we don't have great kind of open standards to access databases. They're very closely tied to the tech that we are using, and that's why it might need some changes to application business logic. Uh, Other aspect is retrofitting this into an existing architecture can be challenging. Like we mentioned, it's it's important to take a flow at a time in your call stack and make it tenancy aware, bring it to the standard that is required for testing in production, and then you can start testing those flows. So yeah, divide and conquer is kind of the trick here that can be applied. So what are some key takeaways? One is that testing in production has numerous advantages and can be a viable long-term solution. Like we saw, it allows you the flexibility of using the same stack for both testing and production, gives fidelity in load testing, allows you to route traffic um, at will and create these custom call graphs where everything else is production except for your sandboxes. That is really why testing in production is a great idea and a viable long-term solution. The second takeaway is that we don't have to reinvent wheel this at this point. There are multiple organizations who have implemented this, and there is a template that can be used. Like we saw some of the challenges and uh, how we have solved those here at DoorDash. So this is there is a prior that we can refer to, and if organizations want to implement it, they should definitely try and reuse the mechanisms here discussed in this deck. Uh, Journey to testing and production starts with tooling to ensure production safety. Production safety is of utmost important. We don't want production to get jeopardized, but we want to get to a level that even if there is an issue for test traffic, we should be equally sensitive to that as well, so that developer productivity doesn't get impacted. And tooling is the key here to make sure that we have the safety guardrails in place, alerting metrics in place in order to achieve this. What's next for DoorDash? We continue to harden tools to catch context propagation issues. That's an ongoing task. We're trying to make it as better and as bulletproof as possible, and we're getting there slowly. Making it easy to do data isolation for legacy applications. They might be on on an old database which does not support well the uh, request context propagation, and that's where the challenge is to migrate those off of those legacy databases to the newer one, which are tenancy aware. uh, Ensuring tenancy awareness exists in all the layers of the architecture. This includes things like when your ETL data flows to data lakes, and whether you want to retain test data there or not. There are other kinds of application that might be running beyond your typical back end or front end applications, where you would have to custom create a solution to make it tenancy aware. Adoption by more and more applications. This is an ongoing battle as well, since there are so many flows and so many of those flows have their own way of testing. Bringing it up to the testing in prod code is a challenge and something that's ongoing. Probably there are a few questions.
Yes, the question is, Nikolai is writing, I suppose that after you
So there's a
execute
question.
tests on
I
production
suppose
DB,
that
some
after you
records are
execute,
created
yeah,
or
go on.
modified, right? Do you hear me, Amit?
Sorry, you cut there a little bit. I'm still going through the question.
Yes. Nikolai is writing, he supposed that after you execute tests on production DB, some records are created or modified. Does it mean that you need to prepare by somehow data in database so it will be ready for next tests execution? So, or you create, modify new records in database so previous tests execution not affect future executions?
Yeah.
Do you approach test records from database or regular basis, or your database size increasing by test data on regular basis? It means.
Yep. Great question. So, um, uh, so test data is created on synthetic data. It's created on production databases and production tables, and and as we know, I mean, the the performance of the DB and the table kind of gets affected if the table gets too large, and if you suddenly start pushing too much of test traffic, where the amount of test data in a table, for example, is quite large as compared to the production, and that will impact production. So yes, so there is a limit to how much of test data exists in production DBs and tables, and the older one gets purged, older data gets purged, and that happens somewhat regularly. But the data cleanup part, I think, um, that depends on how long you want the test data to to stay, so that it's actually meaningful, um, and something that you can glean uh, uh, meaningful results from. So yes, purging is needed, but the how often you do it depends on how long you want to keep it.
Thank you.
Was there another? Okay, good. Yeah. So this is the last slide, really, and with that, we can open up for more questions.
Yep. So let me ask you from my side also. You worked in Uber and DoorDash, and as I know, in Uber they used also such kind of architecture with fish flags, with some deploy train, etc. We had a talk about it on the conference. So, is there any difference between architecture for food delivery and how it's called, taxi service?
Yeah. So there are similarities and differences. Similarity similarities are on the lines of that both have kind of test actors involved. So you create test users and the, let's say, test merchants, and then and work through that, orchestrate a test scenario using those. So that is common across across the two industries, and this is pretty much kind of, I would say, other orgs, companies can also relate to, and then we create the infrastructure for that, being able to create these test actors which reside in a separate tenancy, test tenant actors, and then and being that only the actors in that tenant can interact with each other. So that is one aspect. Other area is what is different is that, I mean, the tech matrix that is being used is quite different. So that is another area where I like to caution, is that the bigger that your tech matrix is, like the number of languages you use, number of databases you support, caching solutions you support, so on, the more you have, more support, um, operational overhead you will have in general. So yes, I mean, this is kind of this classic platform infrastructure issue, that we want to contain the tech matrix as much as possible so that we can provide quality solution for a few, uh, but but a good solution for small but few tech. So that's what I would say.
So if we're talking about, no, for example, if you are going to some startup project, I think it will be overkill if you will start from the beginning with such architecture, right? It should be on some level of company increase. When should you start to think about such architecture?
Yeah, I think sooner the better. And it's if we start thinking about it sooner, like being able to adopt open telemetry and have libraries to isolate the data. I think sooner is the, I would say, is the better. But yeah, I think bringing up the test staging stack for a smaller environment is much easier. But as that scales, as we grow into hundreds of applications, then it becomes quite challenging in terms of application as well as number of developers that we want to parallelly work on those. Yeah, I think sooner we sooner we have the hunch that this is going to be go big in terms of, we should start thinking about testing.
And if you have good DevOps, I think, right? Without without DevOps, it will be impossible. And if we're talking about DevOps, what about deployment? For example, if you want to update all system components, will it be a problem with the tenants?
Yeah, for deployments, we production deployments would happen the way they do. We want to make sure that production deployments of applications, they use things like sandboxes to validate before we go to production. But other than that, they should other than that, it's so this is a validation step of you bringing up a sandbox, running through some test through that before, and then we migrate that code to production. I think what we bring is this allows us to, automating all of this in a high fidelity test environment, and will give you a lot more confidence when you're deploying your change.
Okay, thank you. And we have another one question. Nikolai is saying, if I'm not mistaken, you have integration with third-party services. Are you using some mocks for them, or your tests also affect third-party production system? Or your sandbox pods may use some test environments from third-party vendors, and if everything okay, switch to production endpoints. So do
Yeah,
you
yeah.
use third-party?
Correct. So all of the above. So, for example, for payment gateways, it's great to be able to use sandbox. Theirs connect our sandbox environments to theirs, and that's how we can test end to end different scenarios. But if they don't have those sandbox environments, then either mock it um, internally, or yeah, basically mocking it at an application level, or create a mock that can be used by multiple applications. So yeah, that really, that's a good point. Uh, uh, something that we need to be aware of, for example, because even if there is no harm uh, going to a third party for a particular request, it might harm you in terms of rate limiting, or be getting penalized or getting charged for that test traffic that is showing up on their end.
Okay, thanks. And as I see, there are no other questions. So thanks, Amit. We'll wait you here. If you wish to go to Russia, you're welcome. And thanks for your talk. It was very interesting.
Yeah, definitely.
That's all. Thank you, and have a nice day. Bye bye.
Thank you so much. See you, folks. Bye.
See ya.